Welcome to this session. We have two problems for us to integrate. So the first problem is to integrate sec x dx, and then another integral is dx over e raised power x plus e raised power minus x. Now, sometimes to carry out integration, you need to be very smart before you are able to get the solution to the problem. So let's demonstrate how these integrals are obtained by using some algebraic tricks. So solution. So the integral of sec x dx is what we have to evaluate in the first case. Now what we are going to do, we are going to multiply this integrand by 1. All of us know that when you multiply a function or a number by 1, you are not changing the value of the function. That's what we do. You multiply by 1, and then the function remains to be the sec x. There's nothing we are changing but by multiplying by 1. But then now this one, we write it in a special way. So we write this one as integral sec x times. Now this one, we write it as the sum of sec x plus tan of x divided by the same thing, sec of x plus tan of x, then dx. There's no miracle we have performed, because when you evaluate this one, you still get back your original integrand to be sec x, because the value of this quotient is, the value of this fraction is just 1. But we are writing that 1 in a special way that will help us to get the notion of how the integrand looks like, and then how we can easily get the derivative of that given integrand. Now, by that manipulation, we'll have integral of sec squared x plus sec x tan x divided by sec x plus tan x dx. Now we let this denominator to be u. So let u to be sec x plus tan x. Then this implies, from what we did on differentiation, the u is sec x tan x, and then plus, when you differentiate a tan function, you get a sec squared function, and then dx. So you make dx the subject. So we'll have dx will be du over sec squared x plus sec x tan x. At this point, we should be smiling, because we can see that what we have in the numerator here after this trick is the same thing that we have in this denominator. So therefore, that means that the integral of sec x dx, which is the same as integral sec squared x plus sec x tan x divided by sec x plus tan x dx is the same as integral of sec squared x plus sec x tan x over, we have fixed this one to be u, so u times dx is du over, this is sec squared x plus sec x tan x. And you see these two functions are the same, so they cancel out. This and this cancels out. So we'll have integral of sec x dx equals to integral of just du over u. But from our other discussion, integral of du over u is simply ln of u, then plus c. So therefore, integration of sec x dx is nothing but ln of our u is sec x plus tan x, and then plus c. So that is the solution to that given problem. So whenever you are integrating a sec function, you get ln of sec x plus tan x. And the second problem, we have integral of dx over e raised power x plus e raised power minus x. We do the same game. We write this one as integral 1 over e raised power x plus e raised power minus x. And then we multiply by 1 and then dx. There's nothing I'm changing from the problem. It's still the same. But now this one, we are going to write it in a special way that can help us to have a clear picture on how we can get an integrand whose standard value we know. So we are going to write this one as e raised power x over e raised power x. So 1 over e raised power x plus e raised power minus x. Then this one, we write it as e raised power x divided by e raised power x dx. No miracles have been performed. It's still the same integrand if you do the cancellation. So this will be integral e raised power x divided by e raised power x by this will give us e raised power 2x. E raised power x by this one, so loss of indices, that will give us 1. Because it will be now x plus minus x, that will be 0. E raised power 0, 1. And then this will be dx. Now let u to be e raised power x. Don't forget that when you write e raised power 2x, it's the same thing as writing e raised power x raised power 2. So when you say e raised power 2x, it's the same as u squared, because we'll say that let u to be e raised power x. So then we have integral dx over e raised power x plus e raised power minus x is integral. Now, when you say u is given, so this will have e raised power x over e raised power x. I can write e raised power x squared plus 1 dx. And then this means du is e raised power x dx, which means dx is du over e raised power x. So what we'll do next, we'll write this one as integral e raised power x over, this is u squared plus 1, and then dx will replace by du over e raised power x. And you should see that e raised power x will cancel out. So this one, 1. So the integral will just be integral of du over u squared plus 1. And we should be smiling because This is a standard integral whose value we know. And this is simply the tan inverse of u plus c. These are standard integral. Standard integral. So this is what we get. So therefore now bring back our x variable. We say integral of dx over e raised power x plus e raised power minus x is nothing but tan inverse of e raised power x and then plus c. So this is the solution to that given problem. Thank you.